All right, this is a review for unit test 2. Question 1. Given the graph of the quadratic below, which characteristic is false? So again, very important. False, which means not true. The function is decreasing over the interval of x is greater than 3. So again, interval of x is greater than 3 talks about x-axis. So 3, it's right here. Anything greater than 3, it's saying that the function is decreasing. This is a true statement. The function is negative over the interval of negative infinity and 4, and then 4 to infinity. Again, when we talk about interval, we talk about x-axis right here. So it's going to be negative infinity to 4. Okay, so negative infinity to 4, and then from 4 to positive infinity. It says that the values of the function are negative. That is not true. We have some positive values here, and then some negative values below. Okay, so this is not true. The function values will be negative from negative infinity to this point right here, which would be 1. Okay, so these are all negative values, means the values below 0. And then again, from 5 to positive infinity will be the other set of negative values right here. Okay, now from 1 to 5, the values are above 0. They will be positive. So this is not a true statement, which would be our answer for this question. Okay, it could not be the function has a range of negative infinity to 4, because that is a correct statement. We are going from negative infinity to 4. Okay, so this is also a correct statement. And then the axis of symmetry, it's positive, which is in the middle of our graph. It goes to a positive number 3. So this is also a correct statement. Okay. All right, moving on to question 2. Given a graph of quadratic below, which characteristics are true? So we talk about true statement. Select all that apply. That means that we might have more than one answer. Okay. When x approaches negative infinity, so when x approaches negative infinity, so let's just say from the middle of the function x is traveling this way, it's saying that our function is traveling up, okay, which is correct. All right, the range of the function, it's negative 4 to positive infinity. So let's see, negative 4 to positive infinity. That is also a correct statement. The function is increasing from 3 to positive infinity. So 1, 2, 3 to positive infinity. Okay. So if I make a line right here from 3, function is increasing. That is correct. This function is going to keep spreading wider and wider to positive infinity. Domain of the function is negative infinity to positive infinity. That is also a correct statement. Because again, this function is going to continue to go and spread from negative side to a positive side. Okay. And now 5, it says x is approaching positive infinity. So again, from the middle, x approaches positive infinity. And then my function, it's traveling down. That is not a true statement. My function is right here. So my function would have traveled up. So this is not a true statement. Okay. And now the last one, the function is positive over the interval of negative infinity to 1 and 5 to infinity. So positive from negative infinity to 1. Okay. So all this, because again, it would stop at 1. Okay. And then from 5 toward positive infinity. So again, if I make a line right here, this piece is positive because it's above x-axis. So this is also a correct statement. So all of the statements are correct other than number 5. Okay. All right. Moving on to question 3. The ball is thrown upward from the top of a 40-foot high building at a speed of 80 feet per second. The ball height above ground can be modeled by the equation negative 16t squared plus 80t plus 40. Use decimals where appropriate. Again, let me pull up decimals for you guys. And we're going to plug this function into Desmos. So of course we cannot use t, so we're going to use x. So it's negative 16x squared. Okay. Plus 80x. And let's see, what was the last one? Plus 40. All right, plus 40. Okay. All right, guys. So here's our function. Okay. And I just want to make sure that you guys understand that feet is our y values and speed is going to be our x values, right? So the first question is asking, when does the ball reach the maximum height? So the question is when, in seconds. So of course, the answer is going to be, if you click on the top right here of your maximum, it's going to be 2.5 seconds, okay? Now the second question asks, what is the maximum height of the ball? So of course, then we're referring it to a y value of 140 feet. So let me put that right here. So that's 2.5 seconds and 140 feet. Now this third question is asking, when does the ball hit the ground? And of course, we have to look at the graph right here. All right, click where it touches the ground right here. Okay, after the ball falls. And of course, the question is when. So we talk about time. So it's 5.46 seconds if you round it out. So 5.46 seconds. So again, please use Desmos to answer those questions, okay? All right, number 4 says 2 characteristics of a quadratic function are given. The axis of symmetry is -3. And the function has exactly 1, 0. What does that mean, 1, 0? That means it has one intercept only, okay? So of course, I'm going to eliminate A and B because they have 2 intercepts right here, okay? So it cannot be, could be either C or D because they are touching x-axis at one point only, all right? And now the axis of symmetry, it's going to be at -3. So that means it has to be answer D. Okay, because it's going through -3. Here it's going through +3. Okay, so it has to be answer D. All right, using the graph below, answer the questions that follow the path of the rocket is given by the equation. So again, you guys are given a graph this time. How long is the rocket in the air? Okay, so then again, we're talking about the time when it starts. Okay. It goes all the way, it's still in there, it's still in the way, it's still in there, and then it lands, okay? So how long? Let me see. Seconds, so that's 8 seconds, okay? Because it lands back into the ground at 8 seconds, okay? All right. Now the next question is, what is the maximum height of the rocket? So again, of course, we're going to look at our maximum right here. We talk about feet, okay? So that's our y value. So 256 feet. Okay. How high is the rocket after 7 seconds? So again, we're going to find 7 seconds. Find our point right here and use our y value again. It's 112 feet. Is the rate of change of the height of the rocket greater? Okay. So again, is the rate of change greater? Well, we have to see. First rate of change will be our slope. So again, let's look at the point. We can do, so again, is the rate of change height of rocket greater from 0 to 1 or from 3 to 4? So 0 to 1, okay, so these 2 points, so we can use the slope formula, okay, so this is going to be x1 and y1 and x2 and y2. I'm going to subtract 1 minus 0 because the formula is x2 minus x1 divided by y2 minus y1. Okay, so 1 minus 0 divided by 112 minus 0, so that's 1 over 12. So yes, it is positive and greater. Okay, so that's a yes. All right, so this is a slope formula, okay, rate of change. All right, and next one is, what is the domain for the path of the rocket? So remember, domain cannot be infinity to infinity when we talk about life events. So our domain here it's going to be from 0 to when it lands, okay? When it starts and when it lands, which is this piece right here. So our domain would be 0 to 8, okay, including those points. Now what is the range of the path of the rocket? So again, it cannot come from infinity, so it's going to come from 0 to its highest point, which is 256, okay? So 0 to 256, that's where we see our graph when we're looking up and down. So 0 to 256, all right? All right, and the last one on the interval of 0t to 4. So again, we're looking at the x-axis. So, is the function increasing or decreasing? Okay, so from 0 to 4, okay, when I take this piece and this piece, so from here to here, my function is increasing. Okay. All right, moving on to question number 6. A swim team performs a dive. So this is your diving board. Okay, that's 12. And the graph below shows the path of their dive. The y-axis represents the height. So this is our height. And in feet. So this is going to be feet. I can just write feet here. All right. And then x represents, let me see. And when they are x feet away from the springboard. Okay. And I would assume this represents time in seconds. Okay. All right. What was the height of the springboard? Okay. First, the answer is 12 feet because this is where it started right here. Okay. So 12 feet from the ground. How high was she at the peak of her jump? Okay. It will be right here. And of course, again, we talk about feet, so this will be 60 feet. This is y-axis. How far away from the boat was the diver when she hit the water? Okay. And then, of course, how far away was she? So I guess this says x is feet away, so this is also feet, no time. Okay. So both of their, its height in feet and the feet away from the board. So how far away from the board was the diver when she hit the water? Of course, she hit the water right here at this point right here. Okay, so that's 6 feet away. And then the last question, how far from the board was the diver when she hit the water? How far from the board was the diver when she was on the way down? So this would be decreasing when she started decreasing. Okay. So let's see, she went up here, and then at this point, that's when she started going down. So at this point, at her high peak, so that's 2 feet away from the board. Okay. All right. Next question. The graph representing a quadratic equation, f of x, is shown below. Analyze the graph and identify the requested key characteristics of the graph. Okay, so y-intercept. All right, that's when, function crosses y-axis right here. So that looks like at y equals 6. All right. And we can, of course, write there's a 0.06 as well. All right. Coordinate of the vertex. So that's going to be our minimum right here. So that's going to be 3 and negative 5. Okay. So 3, negative 5. So that's your minimum. Okay. Interval where the function is increasing. So interval means x-axis. Okay. So where is the function increasing? It is increasing from this point right here, from your vertex, all the way to the right. So from your vertex, which is 3, all the way to the right toward positive infinity. Okay. So we include the point 3, and then we go toward positive infinity. We can also write all the x's that are greater or equal to 3. Okay? Now, when is the function decreasing? It's decreasing looking from, always read it left to right, it's decreasing looking from negative infinity, okay, to 3. All right, so all of this comes from the negative side of a negative infinity, open circle, to 3. Okay? So also we could write it as x is less than or equal to 3. So all the values of x, they are going to be on this side, okay, of the 3. All right, now our end behavior, when function is approaching, when x's are approaching negative infinity, so when from the middle again, from your axis of symmetry, when x's are approaching negative side, okay, my function, it's found to be traveling up. And then of course with quadratic equation, it's both ends have to go up, so that means this also have to be going up. But we can check it when from the middle function is approaching positive numbers, my function is also traveling up. Okay. In an interval where the function is positive, so again, the positive numbers are going to be, or parts of the function are going to be the parts that are above x-axis right here, so all these. Okay. So again, we're coming from negative infinity to this point right here. This is where it ends. Okay. So from negative infinity, all right, to 1. And then combined with 5, which is right here, toward positive infinity. Because again, we're looking left to right, and we're looking at the x-axis only. Okay. All right, factor. So factor means it has to be in a factor form. We do not solve it. So, first question, x squared plus 12x plus 35. You can use either quadratic equation if you want to get the factors, but when you solve it, you got to put it in a factor form. But I would prefer to just use the a times c. And to find two factors, I'm going to multiply the first number and the last one, so that's 35, and has to equal to the middle number, that's 12. Two factors and multiply to 35 and give me 12. When I add them, it's 5 and 7. And of course, they're both going to be positive, so I'm going to put x plus 5 into parentheses and x plus 7. And these are my two factors, okay? I do not need to solve it, all right? Now, 9, again, multiply first and last, so it's going to be negative 40. Has to add to 3. So I got 5 and 8. And of course, 5 has to be negative, because I'll do negative 5 plus 8 to give me 3. So if I put it into parentheses, it's x minus 5 and x plus 8. Okay? And I am done with that. 10, okay, multiply 1 times negative 72. It's negative 72 has to equal to negative x. Two factors is 8 and 9. Okay? And of course, 9 has to be negative to give me negative 1. So again, x plus 8, x minus 8. All right. Now, number 11, I'm going to multiply 5 times negative 16. Okay. So that's going to give me negative 80. And it has to add up to 2. So that's going to be 8 and 10. And of course, 8 has to be negative to give me positive 2. So I have x minus 8 and x plus 10. And of course, the one thing we got to remember that this leading coefficient is more than 1. It's a 5. So we got to take both of these factors and divide it by 5. Okay? We cannot forget that. All right, now, negative 8 and 5 do not divide, so the 5 will go in front of it. So it's going to be 5x minus 8. And then 10 does divide by 5, so that's just x plus 2. Okay? And we do not need to solve it, all right? All right, for number 12 right here, I got a 4 and I got a 9. Both of them are both of them are perfect squares. So I'm going to use the square root method because my b equals 0. My b equals 0. Okay, so if my b equals 0, if I'm missing a b, only if I'm missing a b, I can use the square root method if these are perfect squares. So I can square root 4. So square root of 4x squared will equal 2x. And square root of 9 will equal 3. So when I'm putting it into parentheses, okay, it's going to be plus or minus here. Okay, 2x goes in twice. All right. And then I have plus 3 and minus 3 going into both. Okay. And then the last one. All right, I got 4x squared minus 12x plus 9. Again, going to multiply 4 times 9. All right, so it's going to be 36 and it has to equal negative 12. Two factors would be 6 and 6, and they both got to be negative. Okay, so I got x minus 6 and x minus 6, okay, to give me negative 12. Now, of course, again, we have 4 as a leading coefficient, so I got to divide it by 4. Well, this does not divide pretty. So instead of putting the 4 in the front, I can simplify it 6 and a 4. Okay, and divide each of them by 2. So that's 3, and that's 2, that's 3, and that's 2. Okay, so x minus 3 now divided by 2, and x minus 3 divided by 2. Now, since 3 does not divide by 2 anymore, now I can shove it up in the front. Okay. So it's going to be 2x minus 3 and 2x minus 3. I can also write it as 2x minus 3 squared because these two factors are identical. But again, the key here, guys, is to make sure that you're simplifying this right here, the 6 over 4 to 3 over 2. Okay, so anytime you can simplify it, you want to simplify it first. When you cannot simplify it anymore, and the numbers do not divide, then you shove it in the front. Okay? All right. Let's see. Question 14. All right. All right. Question 14. A quadratic has one x-intercept. Which of the following could be this quadratic's in a factor form? So one intercept means that the factors should be the same. Okay, so that means that a function only has one zero. One time that the function touches x-axis, and it would be at negative 1. Because of course when we equal it to 0, x will equal negative 1. So that's when it bounces up at this point and it only touches it one time. Okay, so you would have to have two the same factors with the same signs. Okay, so two the same factors with the same signs. So it will be answer C. Okay. All right, so for number 15, okay, we have 6x squared equals 42. So we can solve it two different ways. We can just simply solve for x, so divide both sides by 6. X squared will equal 7. And then to get rid of the square root right here, we can square root both sides. So this cancels out, becomes an x, and we get a root 7. Okay, plus or minus, of course, because remember, anytime you take a square root, you get two answers. So that would mean our answer would be plus root 7 and negative root 7. Okay, so the correct answer would be B. All right, and then there's a second way to solve it when we just have 6x squared equals 42. We're going to move 42 to the other side. Okay, we get 6x squared minus 42 equals 0. Now, we could, since b is equal 0 here, we could use the square root method, okay? But, of course, 6 and 42 are not a perfect square, so we're going to try to take a greater common factor out first. So we're going to divide both sides by 6, okay? So we get 6, and then left x squared minus 7 equals 0. And now, if we square root both sides, again, square root of x squared will equal x, and square root of 7, we simply leave square root of 7 plus and minus here. We cannot take a root of 7. So when we put it into our parentheses, 6 in the front, we're going to have x and an x plus root 7 and minus root 7. And when we equal it to 0, this is going to be negative root 7, and this is going to be positive root 7. So again, the correct answer would be B. So again, you take the greater common factor out first, and then we're going to square root to make, and we can't make a square root of 7 of anything. Square root of 7 does not simplify it any further, So it just stays in the factor form as a square root of 7. Okay? All right? And then question 16, very quick. Before I end this first part of the video, which quadratic function has a root of -5 and -1? Again, I would simply use Desmos for this question, just to make sure that you could solve every single one of them into a factor form. So this would be factors of -5 has to add to 4, so there would be 1 and 5, and of course 1 has to be negative, so x minus 1 and x plus 5. When you equal it to 0, it would be x equals 1 and x equals -5. So it's not A. We could do exactly the same thing to B. First number multiplied the last one. It has to be -5 and -4. So again, 1 and 5, and of course this time 5 has to be negative. So this would be x plus 1 and x minus 5. When you equal it to 0, this is going to be -1. This is going to be 5. So it's also not B. C, two factors that multiply to -5 and add up to -6. So 1 and 5. Okay, they both have to be negative to give me -6, so that would not work. Okay, and then a positive right here. I would have a +5 and +6, so 1 and 5. This would work, x plus 1, x plus 5. So x will equal -1 and x will equal -5. So this is your correct answer, would be D. But again, if I were you guys, I would simply plug it in. So this was x squared plus, what was it, 6x? Let me see right here real quick. Plus 6x. I'm just going to plug in the last one. And then plus 5 again. So again, you guys looking up here, you're going to see right here -5 and -1. So the x-axis right here, the values are your zeros that your y-intercepts. Okay? All right. So I'm going to end this video on this note and then make a second one for the second part. Okay?